Is it fine? Okay.
Yes, sir. Yes, sir.
Okay. So let me interact with the audience. Okay. So we have Bhanu, Priya,
Yes, sir.
Ipsita. Yes. What actually you are doing now?
Yes, sir. I have joined a company which is based on structural design. In bridge section, I have joined ICT New Delhi.
Okay. Okay. So you did your BTech in master degree?
Yes, sir. Masters in structural engineering from BIT Mesra Ranchi. I just passed
Oh,
out in May 2023,
okay.
and I have
Okay.
joined this month in August only.
Okay. Okay. Fine. Fine. We want another one. We have Ipsita. What actually you are doing? So let me know that actually what is that your audience qualification. So that depending on that, I will go in the deep. Ipsita, Priya, can you hear me? Fine. Okay. So basically here you just see, I'm going to discuss about the structural health monitoring. So structural health monitoring is the topic where what we are going to do, we are basically try to identify the damage location. Okay, so now there is various option that damage location, whether damage is, first of all, we have to identify whether there is a damage or not. Sorry, whether the structure is damaged or not. Okay, if the structure is damaged, then what is the location of the damage? Now, if you are able to identify the location of the damage, then you have to identify how much extent of damage is there. Okay, so first is that you have to identify whether there is damage or not. Next, you have to identify if there is damage, then what is the location. Next, we have to see that what is the severity of the damage. Now, if you are able to identify what is the severity of damage and what is the location of damage, next your idea will be to identify that what is the possible mode of failure. Okay, what is the possible mode of failure, and we can also identify what is the service life. Okay, so the structural health monitoring scheme basically include all the 5 parameters, from the identification of the damage to the remaining service life or possible mode of failure. Okay. Now, the structural health monitoring basically will observe that we can do in various ways, and it also involves lot of, basically you can say that from long time, if you have invested a lot of time to identify the damage. Because initially what earlier what used to do, they used to do the manual one. So if you do not have any idea, then you go on checking on all the details and see whether there is damage or not. Okay, and if you are able to identify the damage, in that case what happens, you have to uh, further you have to analyze it. Okay, so now what happens when we have research development? So nowadays what we are going to do, we are basically measuring some response. The measuring some response, the response can be in the time domain data, it can be frequency domain data. So basically what we are doing, we are measuring the data in in periodic manner, means in a certain interval of time we used to measure the data, time data or frequency data. Okay, and then once we get the data, you have to identify what is the present status of the health or what present status of the structure. Okay, whether the structure is good enough to carry on, or you have to go for some retrofitting or rehabilitation. Okay. Now, if we measure the data, what we have to do, what we can do, we can basically check. Then how we can check? So now here that pattern recognition used to come. Okay, so here we can try to get the pattern. So if you have the measure data, for example, you have in data which earlier used to be like this, but due to the damage or due to some disturbance or due to some local failure, now the response has changed. Okay, so now from the difference from the pattern of the damage, responses you can identify whether there is damage or not. Okay. Now, so this basically the pattern extraction method basically in this topic already various research is going on, that we used to say that AI based research or say artificial intelligence based research or machine learning based research. Okay. And the earlier that Samuel Gucher sir already discussed about that. So now what happens if you have measured the data, okay, and you get some pattern, and from the pattern you can say you can apply some machine learning algorithm or artificial intelligence to get the pattern, and from the pattern basically you identify that whether there is a damage in the structure or not. Okay, now if you see there is a damage in the structure, then you have to go for suitable repair, revision, or strengthening method. Now here, what is the need? So here we have to see whether repairing or revision is sufficient or not. And again, you have to do the cost-effective analysis. Okay, so if you have a building and if you observe that repairing cost is too high, in that case, obviously you have to go for new structure. Okay, you cannot repair or you cannot go for renovation. Okay, so these are the things are there in structural health monitoring. Okay, so here what actually we are doing, our basically aim is to have a reliable method to predict the damage. So we should have a reliable method to predict the damage, and the damage can be small amount also. If the damage is very low, in that case, our methodology, our algorithm should be capable enough to identify the damage. Okay, and the method also should be capable to give the alarm that yes, there is some damage, something is wrong with the structure. Okay, and if it is giving the alarm, then obviously we should go for alternate strengthening method. So this way, basically, we can go for our structure health monitoring of a structure. So now we have also smart structure where we can have a feedback loop. So we used to have some data, we used to capture some data in continuous manner. Okay, and from the real time data we can see. Okay, but again, what I want to emphasize, though the structural health monitoring is a long a topic which has been discussed for a long period of time, still there is a very much scope to do some research. Okay, so next slide I had to discuss that what we can do, what are the limitations we have. Okay, for example, if you consider the structural health monitoring in our using our visual inspection. Okay, in that case, you'll observe that visual inspection we can go, but again, it is very time consuming, expensive. Okay, and in this method, we can only have qualitative that yes, there is some damage, but we cannot quantify that amount of damage. Okay, and some cases we'll also observe that visual inspection is not suitable because many parts are not accessible. So in that case, what we do, we have to go for alternate method. Okay, sometimes visual inspection is a good result, but there is also limitation. Okay, the limitation is that we may not get the access to check for visual inspection. Okay, now what do we do? We have to go for non-destructive testing. So non-destructive testing basically is a testing where we are not going to damage the structure. So how we are going to evaluate the structure? We can put some sensor there and we can measure some response. We can put some sensor in the structure and we can measure response, and from that response we can try to identify that whether there is damage or not. Okay. Now again, there is limitation on the NDT non-destructive evaluation. The limitation is that the person who is dealing with that technique, we need to be educated. Okay, for example, if you go for visual inspection, then a layman can visually inspect it and I can identify the damage. But if you go for entity testing, in that case, the man should be expert. Man should be expert enough to measure the data, and you should be basically acquainted with the technological development. Okay, and whatever the data you are measuring, this should be able to interpret the data. Okay, so basically, what I want to emphasize, the limitation is that where we need to have highly skilled expertise to have the proper monitoring of the structure. Okay. Next, we have the fine relevant modeling based data. Okay, so fine relevant modeling. is also one type of direct observation. So what we can do, we can model the structure in finite element. So probably you're knowing the finite element is a method, one type of numerical approach by which we can model a structure having complicated geometry. Okay, and we can get the response of having a similar structure. Okay, if you have a frame-like structure, then you can model it in FEM, okay, in finite element model, and you can analyze it and you can get some pattern. Again, there is some problem. Problem is there is some limitation. Is that the model should be accurate enough? For example, the boundary conditions. What are the boundary conditions we have in the real building? That same boundary conditions should be there in everywhere. Okay. Just a minute. I have a message. It's called. Just a minute. Hello. Yes, sir. Just a minute. OTP. Okay. Sorry for this term. 975188. Lagwe. 975188. Hey guys, too. One more. Yes, 674305. 674305. Okay. Okay, sorry. So thing is that in the finite element model, still there is some limitation. The limitation is that we should have a proper modeling. Proper modeling in the case, you should have proper modeling of the boundary conditions. You should have proper modeling of the connection. If any connection fail, then again you should have a string model to measure or to represent the damage. Again, the material also you should model because the material which was earlier during the construction, after 10-15 years, the material may not be the same. Okay, so you have to again model the material also. So in the finite model, also you have to be careful while using that methodology. Okay, so now what we can do, we have visual inspection, we have limitations, we have our NDT testings. Again, we have some limitations. We can go for finite element modeling. Again, we have limitation. Okay. Now, what we can go, we can do, we can combine the things. We can combine the NDT testing data, and we can combine the finite element model. Okay. And what we can do, basically, initially, if we update the metal parameter and the geometry, okay, we can, and if you can update it, if you update it, and you can be satisfied with the updated model, which basically represent the actual structure. Okay, now we can deal with the finite element model with the updated boundary conditions, updated metal property. Now we can basically do further analysis, and you can use that model for damage detection or your structural health model. Okay. Okay. So this is the first part. Okay, now we will see that what are the method we have. So if we see, we'll observe that our structural health monitoring is a two type. One is your global based method. One is your global based method, and second one is the local method. So global method means where we use the response which is global in nature. For example, if we use frequency data, the model data, frequency data, you'll observe that frequency is the parameter which represents the frequency of whole structure. So frequency of the whole structure. So then you can say this is our global in nature. Okay. Now, if you measure the acceleration or displacement at any point, you can say that is local in nature. Okay. Okay. So we have two methods. One is your global based method, another is your local based method. Okay. Now, what is the difficulty with the global based method and local based method? Global based method basically difficult is that the response we are measuring, from that you have to see at which parameter basically affecting the global response. Okay. For example, your young modulus, or you can have your change in the geometry, or you can have that EI, okay, which basically if affecting your global response. And local one is that you can see our acceleration data or your wave propagation data. You are basically you have a one structure, we are giving impulse here and you are measuring here. Okay, so if in between if you have damage, then the damage basically interact with the wave, and you can have the differences in the wave input and output. You can use the data for your damage detection. Okay, so our damage detection basically can be global in nature or and local in nature. Okay, now problem is that problem for our civil engineering structure is that our civil engineering structure are very huge in nature. You'll observe that demonstration, the demonstration research, the research which has carried out till now, you'll observe that flow of the research basically is like that. It initially developed in computer science or in the application of ECE. Then it was applied in our aerospace industry, mechanical industry, and then it comes to our civil engineering problem. Okay, so those methods developed for computer science, electronics, or aerospace or mechanical, those methods we are using for a civil engineering problem. For example, our pattern recognition method. Pattern recognition method earlier was developed to categorize our emails. You will observe that in our Gmail, we have spam mail, we have promotional mail, all the things. So what happened that Google have tried to classify the data whether the mail is coming to primary email or it is basically our spam mail or it is our promotional mail, like that. So those email have used to have some pattern, and they have identified the pattern. But the same thing we cannot directly apply in a civil structure. Okay, then now problem. What is the problem? Why you cannot apply that? Problem is that our civil structure are very huge in nature. Our civil structure you observe is very huge in nature, and if there is a fail in one member, then whole structure is not going to collapse. Our indeterminacy of the structure is so high that if one single member fail, if there is a failure in a single member, that is not going to affect the whole structure at all. Okay, so those method which was earlier very suitable for our computer science, and mechanical, aerospace, that method directly you can apply it here. Okay, so why I am saying all the things, because if you are going directly applying those methods to a civil engineering problem, then you have to be very careful. You have to see the method you are using, whether it is suitable for you or not. Okay. And another problem is that you'll observe that our mechanical or aerospace industry, they used to have a prototype. Means if you have a machine, then all the machine used to have the similar in nature. If you have a plane, then all the means a plane of one category will be similar in nature. But our civil engineering structure are very unique. Unique in the sense one structure will not be the same of the second structure. One structure may be a 3-story, another structure may be a 5-story, though that they are planned and the other geometry are same, but one can be 3-story or another can be 5-story, or they are totally different. Okay, so the baseline method which was applicable for one structure may not be applicable for another structure. Okay. And second things I've discussed, that the structure is very huge in nature and we may not get any response at all. So now to vibrate it or to have the deflection or displacement on the structure, you have to apply huge amount of load, and which we don't have that capacity. So you have to think the suitable alternate options to use to have the deflection. Okay. And third option is that this method also is possible. Now what we need to do? So if our structure is unique in nature, then if all the basically you have to go for helmeting of all the structure. Okay, you cannot have the similar pattern for all the structure. You can have a pattern for one building, that pattern may not match with another building. Okay. Okay. Next, what is that? Okay. Now, thing is that here, if we are able to identify the damage in our visual inspection, okay, then you have to model it. If you want to model in FEM, then you have to see how we can model. So, do you have any idea how we can model the structure? How we can model the damage in our structural health monitoring? Can anybody explain? Manu, Nirmala, Sindhu, can you explain that how we can basically model the damage? Oh, fine,
I think
no
sir
problem.
has told, for example, previous presentation, sir was
Yes.
more damage by reducing the thickness. So
Yes. So basically, so what we are doing, we are basically changing the rigidity EI. Okay. Either I means B deco by 12. Okay. So either you can change the B or you can change the depth or basically you can change the Young modulus. Okay. So you'll observe that in our stiffness parameter, EI term used to come. Okay. So EI you can change, either you can change E or we can change I. Again, what we are doing here, you just try to realize we are, whenever we are changing EI, basically we are basically converting the whole problem into a linear problem. Okay, that is the limitation of our structural health monitoring algorithms or structural health monitoring scheme. When the structure is already damaged, that indicates that the structure is already in the non-linear zone, not in the linear zone. Okay, but here what we are doing, we are basically considering though there is damage, but still the structure is behaving in a linear fashion. Okay? Then only we can use that EI or reduction in thickness concept to model it. Okay. So we can model it by reducing the material properties E, or you can change the geometry to model the damage. Now, if you have the damage in the boundary conditions, then what to do? We have to consider a spring and we have to identify the spring constant. So if you have a boundary damage in the boundary, then what to do? We have to model it as a spring. Okay, and you have to find the spring constant. From that, basically, you can use for, from this you can basically go forward for our structural health modeling. Okay. Okay. Now, if you are able to damage, if you are able to model the damage, then we have to see that what are the causes of the damage. So if you are able to identify, if you are going for health monitoring, then obviously you have to go for that. You have to go for the probable cause for the damage. It may be degradation of the material. It can be degradation in the steel. Okay. It can be fatigue crack or developing the crack which is due to the cyclic loading, or it may happen due to the earthquake, sudden earthquake loading, or impact of blast traffic loading, or there can be failure, maybe basically there will be damage, the concrete, okay, maybe due to the sulfur attack or another chemical attack. Okay, so there are various conditions for which there can be a damage in the structures. Okay, so our structural health monitoring scheme basically include all the things. First thing is that identifying the damage. Second is that identifying the location and that severity of the damage. And next, what we will do, we have to see what are the probable causes of the damage. Okay. Okay. Now, if you go for structural health monitoring, then already I've discussed that we have to go for periodically measure the data, and from the measure data, you have to go for the features or pattern. Okay. And again, you have to see that sensitivity of the response. You have to see which parameter is very sensitive to the response. Okay. All the parameter may not be equally sensitive. For example, if you have a frequency data, you have the frequency data or time domain data. you'll observe that Poisson's ratio is not effective, or you can say is not effective as your Young modulus. Okay, Young modulus may be very much effective, or Young modulus may affect the response in higher magnitude in comparison to the Poisson ratio. Okay, so you have to see the which are the parameter is affecting our response. Okay, now again you should have a baseline model, and if you have the baseline model, then again what you have to do, you have to correlate the model. You have to correlate the response of the baseline model and with their actual model. Okay, and you have to go for identification of damage and then remaining service life of the structure. Okay, so this way basically you should approach for your structural health monitoring. Okay, now depending on the severity, that damage identification method basically classifying 5 level, all the things I have discussed, ascertaining the existence of damage, that is come as a level 1, determine the location, that is to come as level 2, in level 3, the type of damage, whether support failure, joint failure, or member failure. Fourth is your assessment of the extent of damage, and fifth one is the prognosis, basically determine the service life of the structure. Okay. Here you can see that each steps the difficulty level is increasing. Okay. In level 1, it is easy whether there is damage or not. That to identify that is comparatively easy than the fifth point. Okay, or level 5. Okay, so now let me ask if you have any doubt. If you have any doubt, please let me know, and I can proceed further.
Subhajit sir, I have one question.
Yes.
So you are saying we can quantify the damage and that. Suppose we have a building, and
Yes.
In that area earthquake has occurred, and then
Yes.
the building there will be some damage
Yes.
because of the earthquake. How do
Yes.
you go about identifying the like how do you assess whether the building will be safe, whether we can safely stay in the building, or we have to demolish the building and construct it?
Now again you have to go for that assessment, full assessment. You have to see whether that earthquake causes the failure of several members, whether earthquake causes the failure of the column. If you observe that there is a failure, many various columns failed due to that earthquake, obviously you have to take proper precautions, because that is the which is going to take the load. Okay, if the failure is a single beam or in a wall non-structural member, then you can use that building. So again you have to see, you have to go for visual inspections in that cases, and we have to see that what is the severity of damage, whether there is a structural member failure or non-structural member failure. And if the structural failure, then which member has failed, whether column failed or beam failed or slab failed. Okay, so depending on that you have to suggest. Okay, and again you have to see whether that structure can be retrofitted or not. If you observe that yes, there is some local failure in one member, then and you can go for retrofitting. Okay, all the things you have to see.
Okay, thanks.
Do you have any doubt from the our participant side? Okay. Okay, now we already discussed that we can have find element model. Okay, and we can go for our pattern recognitions. Now here, depending on that methodology, there are various schemes. For example, our gradient-based method. Gradient-based method basically what it is to say, it basically is to consider the gradient, okay, and try to identify that, try to match the response of your observed data and our numerical model data. And from that, it can identify the damage. That is one gradient-based method. What Samu sir was discussing, that your statistical pattern recognition based method. It can be ANN, it can be support vector algorithm, or any other AI method. Basically deals with the pattern recognition. Another is that your meta heuristic based method, where we have baseline. Okay, so now here you just see the baseline means where you know the properties of the structure, you know the material properties, you know the geometric properties, and you can model it and you can get the response. From that you can identify the damage. But there is another method which is baseline free method, where you don't know from where the response is coming. You don't know that what is the source of the response of the, you can say what is the source of that response means you do not have any idea whether the response is belonging to the structure, a concrete structure, or the response is belonging to a bridge model, all the things. Okay, but from the base, from the data itself, you have tried to identify the damage. So that is basically your baseline free model. Okay, so you'll observe that with the baseline model itself, it is very difficult to identify the damage. If you go for baseline free method, again you have to take proper precaution, because you do not have any idea what type of response or what type of structure you are basically dealing with, and you are basically trying to identifying the health of the data. Okay, so we have various schemes. One is your gradient based method, another is your statistical based method, another is your meta heuristic based method, another is your method which is basically baseline free data. Okay. So here what I was discussing, that if you have a data, okay, and the data should be sensitive to the parameters. For example, that I discussed the Poisson ratio E. Okay, if you have composite structure, you'll observe that composite is to have various parameters E1, E2, E3, G12, G23, Poisson ratio 1, 1, 2, 1, 3, like that. Okay, and if you measure the natural frequency, you'll observe that all the parameters are not sensitive enough to the natural frequency of the motions. So that sensitive features also you need to extract. Otherwise, whether you use SVM, whether you use ANN, or whether you use other method, no method is going to give you the satisfactory result, because the data itself is not sensitive enough. Now, sensitive features, basically you'll observe the different method use different term for that. For example, genetic algorithms, you'll observe that they use that your mutation and crossover, and they basically considering the best fit, okay, or best data. Okay, in that case, we'll observe that the data which is not sensitive, they're ignoring. Basically, in the other way, basically what they are doing, they are identifying the sensitive data, but in terms of crossover and the mutations, okay, or the best fit data. So what I was discussing, that our method where we have our baseline data, we have the baseline, we have the FE model, find relevant model. We have the either time data, or we can have frequency domain data. It can be FRF or frequency and the mode shifts. From that, we can try to get our sensitive parameter or some features, and using that features, we can use. We can basically you can use that features in our support vector machine algorithms or ANN or our gradient based method to identify the damages. Okay. Now, if you go for other integrated testings, you will observe that we have other method. For example, acoustic method, we have ultrasonic method, okay, we have radiographic method, we have thermal method, or eddy current method, through which also we can detect the damage. Okay, so here basically structural health monitoring using non-destructive evaluations. Okay, non-destructive evaluation means where we are not going to damage the structure. Okay.
Sir, I have a question, sir.
Yes, sir.
What is the difference between acoustic method and ultrasonic method?
So basically, see, it's depend upon the range of your wave you are providing. Basically, wave in the ultrasonic, basically is that the wave you are sending, the range is very high, in 10⁹ range. Okay, so acoustic basically is range is low. Basically, the wave we are providing, depending on that. basically lambda, the wavelength, and the magnitude. So wavelength and magnitude, okay, or frequency you can say. Depending on the stage, basically these two different, nothing else. Okay, another basically vibration based already I have discussed that. Gusha sir also have discussed that we have fine tuned model, we have experimental data, and you just compare it. You just try to get the pattern, and from the pattern you use ANN method, or you can use another machine learning algorithm to identify the damage. Okay, and in NDT testings, we already discussed the acoustic, ultrasonic, all the things we have. I'm going to show you that how we can use that method. And then we have vibration based method. Vibration method already someone already discussed it. Okay. Another method is that a static deflection, that the demonstration is using static data, but thing is that it is very difficult to get the deflection in a static conditions. You will apply huge amount of load, okay, and uh, measuring the deflection in real structure is difficult. So best way is that either you go for vibration based method, you can structure the free vibration data. Okay, when the vehicles passes through a building or through that road, okay, you will observe that the structure is to vibrate, and the structure is to vibrate. That vibration we used to call the free vibration. Okay, and from that data you can basically identify the damage. So one easy way is that you go for vibration based damage detection and try to identify the damage by applying some suitable algorithm. And to apply the suitable algorithms, what I was saying that we can have one baseline based method, another is a baseline free method. Okay. Now what happened if you go for baseline based method, then you have to go for one finite model. You have the real model, and both the cases you are basically measuring the dynamic response or acceleration frequency, all the things, and you try to compare whatever the discrepancy you have. You try to first identify the discrepancy and remove the discrepancy and update the model. Okay, once you update the model, and from the updated model you can use for monitoring of the structure. Again, how many parameter you are choosing, depending on that also our algorithm is to be. Okay, if you have a large number of parameter, you will observe that no demonstration algorithm will give you suitable or acceptable data. First parameter is that you have to reduce the parameter. Okay, for example, if you have building and a large building, you have 100 columns or 1,000 columns, 1,000 beams, and you are running for all the beams on all the columns, you will observe that no method giving you the good result. The first thing is that you have to go for reduced number of parameter, and from that only you can identify, from that reduced parameter you can apply method. You can use AI based method or you can use gradient based method, and using that you can identify the damages. Okay, here you just see. So that things I was discussing, that is your global method. Vibration based method is global method because you are measuring the frequency, which is frequency of the structure, which is global in nature. Okay, apart from the global method, we can have local method, that is your ultrasonic pulse velocity method. Here basically we are providing the pulse, okay, what frequency you are providing, and we are trying to see that how much time it is taking to travel. Okay, so we know that distance, we know the what is the velocity, from that we can find. Okay, so we can measure directly, or we can measure indirect way, or we can measure in semi-direct way, and if we know that what actually the velocity should be, okay, and from there you can identify if there is some damage, it will interact with the damage and it will delay the travel time, and from there we can identify the damage. Another impact echo, again all the things basically you'll observe that it is basically differ depending on the your lambda, wavelength, and the frequency. Okay. So here also you can see that impact echo you can use to detect the damages. Okay. Another is your ultrasonic guided wave method. So here, what we are going to do, we have one PJT, piezoelectric transducer. Okay. So here in the right side, you can see we have piezoelectric transducer through which basically you are providing the impulse, and we have sensor here. Okay. and we are measuring it. And if there is some damage in here, somewhere here, we can locate the damage. Okay. Another is radiographic method. Radiographic method also has been implemented for detect the damage in a pipe-like structures, or gas pipeline or other pipeline. Okay. Here basically we use this one. You can see that implementation of the radiography, okay, in real life. Another is X-ray gamma ray, but this has not been used in civil engineering problem in huge manner. But again, that is used for our human body, but that also can be implemented in our civil engineering structure in a smaller scale. Okay. So another is that your infrared thermography. So infrared thermography basically try to see the difference in the temperature, and if there is some crack or there is some seepage, so from that basically try to get the temperature difference, and it can identify the damage location. So these are the things we have, which basically deals with the non-destructive testings through which we can identify the damages. Okay, so let me stop it here. If you have any queries, please let me know.
Thank you, sir. Audience,
Yes.
please ask questions.
So I tried to shortcut all the things. I did not enter in all the numerical part. So I was not getting what is the level of the audience. I try to make it as simple so that people can understand that though it look very attractive, but there's a lot of difficulties are there. Okay, from having the baseline model, from your identifying the locations, from your quality of data, whether it is time domain data or frequency domain data, all the things are there. Okay, but though it is look very attractive, but real application is really challenging. So you can go for it, but again you have to think that this is not a easy task. There are a lot of things involved there. But you can use infrared, you can use other your local based method, which can identify the damage, and you can use that.
Sir, I have a question.
Yes,
Suppose
yes.
You have a plate.
Yes.
And suppose there is a damage in the plate.
Yes.
At what frequency you should vibrate the plate to detect the damage? It should be
No,
like the first mode. Suppose
no,
first
thing
mode
is,
or
see,
second mode. Or
no, it's like that. The first mode, if you observe, first mode is always a global mode. Second one also.
Yeah.
Now, if you see that your deflected profile mode shapes. First mode always your global mode. Second mode you can have the second curvature. Third mode have that more curvature. Okay. So whenever you are going for higher mode shapes, basically you can see you have a lot of curve there in the deflected shapes. Okay. Now if you are going for higher mode, obviously there is a high chance that it will interact with the damage, and you can easily identify the damage.
So can we say that if you are measuring the FRF
Yes.
for a body, then
Yes.
the presence of damage will affect the higher modes more than the smaller modes?
Yes, you can say FRF is local in nature. Okay. FRF is local in nature. So you can have to see what is the position of that accelerometer from where you are measuring the response. So FRF is local. Now, when you are saying that higher mode, that means you're saying that mode shapes.
Yeah.
Okay.
I'm
So
saying about,
you have to stay in terms of mode shapes. So in that, if you say mode shape, then you can say yes, it will be easy for you to identify the damage if you use higher mode. Now, problem is that all the structure is to consume almost all the energy to vibrate in the first mode or second mode itself. Okay. So in real life, if you have a huge structure, you will observe that you can also try to realize that if this is your plate. Now, for this case, first mode is like this. You can see that it is very easy to deflect. Means it is taking less amount of energy to deflect.
Yes. Yeah.
Now, if you want to go for second mode, now you just see, now I have to use more, I have to apply more effort. That means I need to have more energy to vibrate in second mode.
Yes.
Now, if you go for third mode, means you need to go for higher energy.
Yes, yes.
Okay, so structure has a tendency to vibrate in the first mode itself. Now, if you want to go for higher mode, that means you have to impart huge amount of energy to deflect the structure in the second mode or in higher mode.
Yeah,
So,
yeah.
so it is very difficult, though in simple you can say simple beam or simple plate, you can go for higher mode. It's fine. But when you go for huge structure, it is very difficult to vibrate the structure in higher mode. So you have to go for local accelerometer, and from that data you can uh, you use, and from the data you have to try to get the pattern, and from that you have to identify the damage locations, and then from the shift in the natural frequencies you can get the simulate the damage.
Okay, sir. So questions from the audience. Sir.
I
Can
don't know
ask
how much audience got from me.
they are-
Okay, so if they don't have any doubt. Okay, one more thing, you can see that I have some video. I try to make some video. Okay, and in that video, basically, I have fine element modeling. Okay, so you can go through it. Actually, I used to take one class. That class is of your fine element modeling of the structure. Okay, so if you want to learn about the fine element modeling, in that case, you can go through the link. Okay, so
Sir, you
I'm
can
putting
share
the
in the
link.
chat on
Yeah,
chat.
I am
You can
giving. I
chat,
am
you can
giving
just
it.
type that
Yes.
link.
Okay, and this part. Okay, so you can go through, and there is various small topic, important topic I also have discussed. You can go through it, and so that you